Very good. I see better results this time. Yeah, the quiz is over now. Thanks for participation. When you attended every question, you also got the answer along with you, along with whether it was correct or wrong. I think you learned something from this quiz. Alok, can we start?
Yes, Girish, we can start now.
Yeah, if there is any question from the last session, please ask. Otherwise, I have just one question. Alok, can you just quickly tell us about the hash function, or is it part of today's class?
No, I briefly can tell what is hash function.
And why it is required? Something maybe refresher will be a better.
Yeah, right. So a hash function is a data structure, hash table basically. Basically, hash table is a data structure, very popular, where we try to find something very quickly, whether in that item is there present in the table or not. So this is very useful when we store many things in a data structure and quickly check whether there is a duplication or not. So that is the thing we need, and if that is there, then something like that. So there are many ways to do that. So simple data structure is array, but for array, what you have to do, you have to loop over the indexes from 0 to n, and check every item, whether that item is there or not. That is one way. That is the simplest way, but the easiest way is the most time consuming. There are other ways also. Instead of array, there could be linked list, doubly linked list, circular linked list, and again you have to traverse through the list and check each item. Instead of that, that takes a lot of time. Instead of that, what the researchers has done, they have created something called hash table. So each item is not stored as that item. They run a function on that item. That item could be anything: a record, a, a string, a name, pointer, anything, any kind of data type that could be. But they run a function on that. That function will give you a number kind of thing, which is called key. And that key and its value is the item is stored as a pair in the data structure. So whenever that key becomes the index in that data structure, so that whenever you come across any item, you can run the hash function on that, get the key, and immediately you can go to that key in the table and check the item. So here the search becomes only one order, like one time kind of search. But in array, for n item, you maximum you have to search for n times. N time comparison should be there. So order of n. Here it is order of 1. That is the advantage the people can get by using hash table. So that is a very short description of a hash table and its usefulness.
Okay, thank you. That was clear.
Okay then. So let me start today's session. Thank you for attending. Again, it is a long weekend, and thanks for being with us. Today we will talk about the second half of the parser development, which is the yuck portion, means the grammar. So let me share my screen. Okay. Okay. So where we were, we completed command line parsing, then we started language parsing. In language parsing, there were two halves. One is lexical token creation, and now today we'll be discussing about the using those tokens to create the rules or grammar of the language. How to create that? So that is our topic of discussion today. So we showed that this is something called the spec. For Verilog, it is 1361, 64 basically, IEEE standard, and it has all the description about the language. Sometimes instead of spec, sometimes people call it LRM, Language Reference Manual. So Verilog LRM is basically this one, and we have to look. So I showed you what is the syntax definition and all those stuff. And this is our bread and butter. For not our, means whoever develops any compiler, they have to go to this annex where the formal syntax definition is given. This is the first hub. lexical token, what is white space, what is comment, what is what, all these things and keywords are listed in this section. But in this annexure, it describes the grammar, actually the rule of the language. So let me show you again this file. This is the LRM, language reference manual, or the IEEE standard spec. And here we have to go to the table of content, and after all the chapters there will be annex. These are listed mostly for all the other languages also. Mostly this comes in the as part of annex. It doesn't come as part of any of the chapters. So this is the formal syntax definition, 711 page. So I will go here and let me see what is listed. This is how one should do. This is the formal syntax definition. So here it says that how, what is the legal way to write a Verilog file. This is the description. This is not a language. Okay, this is not a language. This is a kind of convention, or the way all the compilers syntax is defined in this way. Something, then double colon equals to some kind of operators and some kind of descriptions. I'll explain it in detail today. So if you can see here, library text is something called library. So Verilog can have library, and then library description in the right hand side of the double colon equals to. Then again this library description is again expanded or explained here. What it is meant by the library description, that is this or this or this or that. So this is the format. Again, each of these items further elaborated in the following lines. This is how it looks like for every language. If you define, if you are trying to write a compiler for IPExact or a Liberty library file or anything like that, this should be the common. Generally, we come across this kind of descriptions as a rule. So we'll not bother much about this thing, library source text, configuration source text. This is little advanced, and whatever we are familiar with as a student, and most of the engineers also, we start with module, right? The first thing in Verilog, we write module, and how this rule looks like. So it is not that you should not do this. You can do it, but most practical things I'll be discussing, so that you can also relate to your day-to-day learnings, or whatever you are being taught in your colleges or in companies or like that. So module is the main starting point for most of us, those who do the digital design. So what is the grammar? How it should be written? Source text. What is source text? Nobody knows. So I'll tell you how it happens. So first thing, they have given source text, then description within curly braces. Each of this item has meaning. This curly braces means there could be a description, or there may not be a description. If it is only description, then the description is must. Within curly braces means description is optional. So that is one kind of thing. Then what is description? This description could be module declaration, and this operator. This is OR. In our logic also, this is OR operator. Here also for the language definition, syntax definition, it is also the same meaning, OR. Or UDP declaration means either there could be module declaration or UDP. UDP is a kind of module. user defined primitives that could be there. So if at all there is a description, that there is this description can be either a description of a module or a description of user defined primitive. This is how we should interpret this kind of cryptic writing, cryptic definition of the syntax. Source text double clone equals to within curly braces description means source text, the basically the whole main language may have a description. If it has a description, that description should be either a declaration of module and a declaration, or not and, or a module or UDP declaration. So that means you can have module and or anything is fine. You can have either module or UDP, and this description means one or more occurrence of this. That means one or more occurrence of module and or one or more occurrence of UDP. This is how we should decode this kind of syntax definition. Then what is a module declaration? Again, it is unfolded here. Module declaration is like same double colon equals to attribute instance something. Don't worry about this. What is this? You don't have to understand each and everything. Something within curly braces means it could be one or more occurrence of this item. Then see module keyword. There one module keyword will come here. After that module identifier, the name of the module will come. Then within square bracket, it has another significance. Square bracket means 0. It could be omitted also, optional. Square bracket means optional. Curly bracket means one or more occurrence. Square bracket means optional item. It can be there, may not be there. So module parameter port list. After that, there could be another optional item, list of ports. Then see this semicolon. Semicolon is actually this character semicolon should come. Then within again curly braces, module item means one or more occurrences of module item, means what can come inside a module. After that, this end module, this keyword should come. This is the declaration of the module. Now, if you see, again, this is clarified here. Module keyword could be this module. The bold letter means actually this, the actual text module or macro module, anything, either of this, or this could be there. And what could be the module parameter port list? Here module parameter port list is listed here. Then it is again unfolded here. It is described here. So, and this is on and on, like page after page, everything will be explained. And it starts from this source text. Source text, what is source text? It is described. Then this is again described. Then again the right hand side are described, each of them. Then again the right hand side of these things are again described. This is how it happens. Let me know if you have any questions. This is not a language. You don't have to learn it. But this is how the syntax is defined in every language standards or LRM. And this left side, which is again like kind of elaborated or described further, is called non-terminal. This is a very important concept. Whenever if you are facing any interview, they might ask what is a non-terminal, what is a terminal, like that. So this is non-terminal, means it is again defined, and these right hand sides are also defined. If that is the case, then the left hand side, this is called non-terminal. But if you see module keyword, it's a keyword, actual module and macro module, and you will never see any kind of further clarification on module or macro module. Means here it ends. So module keyword becomes a terminal, means it terminates. The recursion terminates here, but which doesn't terminate is called non-terminal. So the rule consists of terminals and non-terminals. When we write YAC, that grammar in YAC language, we'll know further what is the significance of terminal and non-terminal. And this is how it.
Hello?
Hello.
Alok, Girish here.
Yeah.
Just one question. So can we call the keywords as terminal? All
Yes.
keywords? All
Yes.
keywords.
Yes.
Okay.
It's terminal. So this goes. Yeah. Further question.
No, please go ahead.
Okay. So this goes on and on. Each and everything like will be defined, which will be fully defined. There will be no ambiguity, no undefined thing. Each of these things will be defined unless it is defined, unless everything becomes a terminal. This file will this pages will go on and on and on. That creates all the rules, all the grammars of the language. This is how it works. Coming back to the presentation, so this is the right side is the same rule, and we have then talked more about lexical scanner. All these things we have done in the last session, and we have explained it extensively, like how each keyword character is scanned, and out of that we create tokens, and these tokens are returned like C language, like C function. The way we return from C functions, that we return from lex file, and that we will be using today for our YAC. And this is another gperf. This is specially dedicated for the keywords. So whatever name comes, that name could be the name of an item, or that item keyword also, that can be then. So to distinguish between them, we need this hash function. Now creating the parser. Today we'll start from here. So every
Alok, I have one
language.
more question.
Yeah, sure.
This hash function, do we use only for identifying the keywords?
Identifying the keywords for compiler. So this is a generic data structure.
Yeah.
It is used in many other places, but in compiler development, this hash function is used for identifying keywords.
Oh, okay. Yeah, please go ahead.
Every language has a grammar. Any English, French, Kannada, Bengali, anything. So this is a simple English language. I am writing a parser. So what is I? I is the subject. After that, verb should come, and after that, there may be an article, may not be article, or after that a parser object. This is the rule or syntax of a English language, and this is for human beings. if we omit something or slightly do wrong thing or severe wrong thing, like if I tell I parts are writing, still we'll be able to understand what the other person is trying to convey, because we are human beings. But for computer languages, this is absolutely no. You cannot break the rule. The moment you break the syntax rule, you always faced it in while coding C or Java. It immediately gives that error, syntax error, and nothing is created. So this is how the Verilog language looks like. Module, then module name, uh, then first is the keyword module, then it is the identifier, name of the module, then bracket, like open parenthesis, then list of ports is separated by comma, and after that close parenthesis, then semicolon. This is how you should write. If this comma comes after and, immediately you will get an error. So how to create that error? Somebody has created that code. Today we'll see how to do that. Nothing is automatic, nothing is like coming out of the blue. Everything, some human being has done it. So we'll do it again. So here the rule is keyword, and these are all the identifiers. Identifier means some kind of string, like names, and, out, in one, into. Basically what are this? They are array of characters. If I tell in the language of computer science, they are a stream of characters, a bunch of characters. Module is also same, a bunch of characters. So these are called string, basically. So the strings which are not keywords are called identifier. Basically, they're the name. This is the name of a module, this is the name of a port connection, like that. Then parenthesis, this is also part of the rule, and it is explicitly defined, as you have seen there in the LRM, language reference manual, that it is specifically defined. You cannot use a curly braces here in place, immediately will get a syntax error. And a parenthesis should be there, and the ports should be separated by comma, and at the end there should be semicolon. So this is the precisely written in the language reference manual. So this is the language of Verilog digital design. The above is the language of human beings. This is the language of a computer. We use Yak. Yak basically is paid. There is another a version of Yak which is called Bison that people use. Generally, we don't use Yak nowadays, but they are same actually. So we will call all the time Yak, and but actually we will be using Bison. Just we Yak means we refer to Bison. So Yak, the full form is yet another compiler. So here this language is a language to build another language. That's why it is called compiler. A compiler which builds another compiler. So Yak is that kind of language. And what it can do, LALR. One means look ahead, one left to right. Means this language, this compiler creator will read the text from left to right, and it can look ahead, one token ahead. All these are tokens. So it will read this, and it will read this also, and keep it as a buffer, so that based on that it can take some decision. But this is most of the languages, computer languages, are LALR1. There are LALR2, 3, or other kind of languages also, but as a electronics engineer, don't need to get into that. That is a pure computer science topic. Language structure, LALR grammar, and all those things, other different kind of grammars, all those are kind of abstract mathematics, or is a subject of computer science. So we'll not get into that. But for the sake of interview, yes, Verilog is a follows a LALR1 grammar, and YAK is the language for creating LALR1 grammar compiler. Bison is used to convert context-free grammar into C program, and this is also called context-free grammar, which is kind of, I also don't know what is context-free grammar, and that is again a very deep topic into computer science. We'll not get into that, but it is a context-free grammar. And YAK should be integrated with Lex and gperf, and we'll show this in while we do hands-on things. Any questions so far? So this is the creating grammar. We have already showed you, and here I have only taken the module description, and you can take a look briefly once again, one more time, because I have already described this. This is the syntax. This is how it is defined. So what is this? Now the interesting thing, how you convert this thing into YAK. So this is how it looks like. This is a snapshot of a open source Verilog compiler called iVerilog. This is how it is written. See, source text. Here source text, but here we are not using double colon equals to or this curly braces, all these things. This is for understanding. Here the actual thing is this single colon is there. Then you do this thing. See this technique. Source text is equals to, maybe you can say equals to something, time unit declaration. Opt means optional. Okay, now description list, where this is given description list, but this time units declaration opt was not there here. So based on the experience, the developer has added this. Sometimes we do it, but now you may ignore it. Now let's take this one, description. Here they have said description list. You can say my description whatever is. It is not necessary that exactly you have to follow this word, not necessary, but you have to follow the spirit of this thing. This means one or more description. Here how it is achieved, description list, or see empty, nothing. So that means there could be a list, may not be a list. This is how we create optional sense of optional occurrence, like that. Then description list is what? A description, again description list, then description. This is called recursion. This means what is a description list? Description list could be one description or one description and another list of description. This description list is inside itself, inside this recursion. So if you unfold it, like it will become description. So this essentially mean through a recursion kind of concept, that it is a one or more occurrence of description. This is very important. This is little bit of kind of tricky, but you have to understand. Sometime in interview, they may ask like this. Uh, how do you create a list of one or more things in Yak? So this is by this kind of techniques called recursion. Then again, what is a description? Description could be module, UDP, config declaration, nature declaration, blah blah blah. Maybe they have followed some other standard. I think 2005. Yes, this is 2001, and it is saying that it has followed 2005. So it is little bit more added. Here it was only module and UDP up to 2001, but maybe for 2005 I don't have that LRM. Maybe these are all added here. So whatever maybe, this is how. See, this description is module UDP. At least module UDP is the here. According to more things in a later stage, they have added all these things. So this is how you build your grammar using Yak. This language is called Yak. And this KK attribute, identifier, blah blah. Then this bracket, what is there in the C code, we'll come to that later. So this is the start. It looks like almost the lex file, zipper file, the same kind of thing. This is the starting of the rule making, and this creates a rule. Source text colon then semicolon. This is a rule, but it is incomplete because this has to be described also. This is also described here, but still you can say that this creates a rule, but this rule is more described below like that. But you can say this is a rule, or rule after unfolding everything. This actually will create a big thing, big rule. This is a rule, and this technique is called recursion. And by this we can create one or more occurrence of something, and these are called items, which could be any of the list. In this list there could be different type of items could be there, and you have to list using or things. Or means this may be there, this may be there, or and also there could be module or UDP and UDP. Anything is fine. This is how it works. Grammar of the module. I have just taken the snapshot of the module. Module could be, what is module? Attribute list, blah blah blah. All these things are there. Then module package, module parameter, port list, opt, all we'll see later. And then module end. So what is module start? Again, module start, see, is being elaborated here. It could be K module, K macro module, and program interface. I think these two is added in 2005 LRM. And module end could be this. So for this are coming from gperf. All the keywords are coming from gperf, and this is a C code. We'll show it in the next session, how to build design tree, how to store information. We'll use this thing. Lex also we used C code. Here in Yak also we can use C code. And this is called terminal. Means here K end module, these are all keywords, and you don't need to define those things. Why? Because they will be coming from gperf. It is defined and there it ends. So no more further elaboration of those things. So that means this is called terminal. And this is non-terminal because this is being elaborated further, and it ends here non-terminal. So there are few interesting things which happens as a compiler developer. You have to deal with it every day. Like what is the job of a compiler developer? You will be maybe starting from scratch maybe, and if not, then any question? Okay, if
There,
not,
Alok, there is one
yeah,
question.
yeah.
He says, what is the use of terminal?
What is the use of
Terminal.
terminal? Ends a rule. Otherwise, if we somewhere in recursion, we have to end the recursion. Otherwise it will be in endless loop. The program will go into endless loop. We don't want that. The rule has to end. Why we use non-terminal? Because otherwise we can use may not use non-terminal. Then in one line we have to write such a big kind of rule that is difficult to handle for a human developer. That's why we break the big thing into small thing, we name it, and then again we define that thing. So what we break things small, we give that name. That name is non-terminal. But at the end, all non-terminal has to be like terminated. Like there should not be endless this kind of things. So that's why we need a terminal. I hope that answers.
Yeah, actually, maybe one exam. I think some of them do not have the background of computer science.
Okay,
I whoever have problem understand recursion, I encourage you to understand how the factorial works, and that is very easy to understand. Factorial of n is how do you define n? Factorial n, and you can keep on reducing it till you go to n one.
correct,
Yeah.
correct. See,
If you look at the
factorial
case of, yeah, yeah.
in factorial 5 means 5 into factorial 4. What is factorial 4? Factorial 4 is equals to 4 into factorial 3. So we can write one function factorial n, and inside the function we call that same function again, but with a condition that if n equals to 0, do not call it. So that means there the recursion ends. Otherwise it will go on and on and on, and it will create the computer will hang.
Zero becomes a terminal right there.
Correct. 0 becomes the terminal. So that is the concept of recursion. Here, that 0 you can take as kind of some keywords or identifier or something which is coming from either gperf or lex, some token. That is the terminal thing, token. So as a compiler developer, this is our daily job. So there will be requests for um, enhancing the grammar, enhancing the parser. Why? Today we'll see why this request comes. And this is your job as a compiler developer. If you are working in synopsis or metagraphics, if you are given, you are a part of like vcs team or model sim team, you will get requests to enhance the grammar or the parser. So that means you have to add new rule. Whenever you add a new rule, there could be these two type of problems. One is shift reduce conflicts, one is reduce conflicts. But still, this is highly conceptual, and sometimes you have to think a lot why this is coming. This comes, both of these problem conflicts comes because of the ambiguity in the grammar. Means the yak, when it is reading, it is not, there could be two rules which looks same, and same means with respect to the next token. But for the two rules, suppose three non-terminals are red and okay matched, the fourth token could be different, then it is okay, it is able to understand what is has to be done. But if the next token is also same, and one rule is trying to end and other rule is trying to again shift, maybe I'm not able to explain because this needs a little serious discussion. So there could be a problem. Either you decide that okay, I'm done with this rule, I have got all the items, now I can make this is a rule. Again, there could be ambiguity based on the next token that is read by the legs, that you may think like, no, I cannot say that rule has already completed. There are further things I'll have to check. So when this ambiguity comes, then the yuck gives an error output called shift reduce conflict or reduce conflict. So one rule completes, but other one does not. That is the problem. Should be resolved by precedence or rewriting. Precedence is kind of like, if you remember the Bodmash rule, right? Which is the like plus minus division, which comes first. If you get a division, you can do the operation, but if you are getting plus and next division is coming, then you have to wait. You cannot add these two numbers. You have to wait for other things also, like that. Those are called precedents. Based on precedence also, you can take decision, okay, the rule is done. Or there could be problem in you only, that you have written in a wrong way, or you have understood the grammar in a different way. That's why you are not able to comprehend properly, and yak is confused because of that. So this is all about shift reduce conflicts. And since I'm covering the compiler yak, I have to discuss. But do not get no need to get into very deep into it. Whenever you get a chance, you will face it, then you take help of somebody, or you can also like ping me, then probably I'll be able to explain even further in a more crisp way. um, reduce conflicts is definitely a mistake by us, the developer. uh, LRM never has two same rules. They'll never create exactly two same rules. It is our mistake to understand them, and we have done something wrong, and definitely we have to resolve it. And precedence will not work here for reduce conflict. It is definitely a mistake by the developer. So this is what we wanted to show today as a lecture. And now I want to start the hands-on coding. And if you have any questions, you can ask now or later, or you can take a break. Yes, you can take a break for a minute or so. I'll also take a break. And after that, and if you have a question, you can note it down, you can ask. Or if you don't have a question for a minute or so, then I'll go to the coding part. And I'll show how to build a Verilog compiler today. Okay, I'm back. I hope, yeah, this is quite involved a topic, but don't worry about it. When I'll show you the hands-on, then it'll be easy. Believe me, it'll be easy, and definitely we'll be able to create something. In theory, yes, it's a lot of thing, but let us get back to work. And so what we had earlier we were like, let's create or something like that. Okay. So now what I have added, let me edit once more, like that. It was our this kind of function we were there. So this was our main function, and there was nothing. I just showed how to compile it like that. Now um, we need to do some kind of basic things where we need to do something. So here, as a variable, status is equal to 0. 0 means all good. Now bare minimum we will add like status status equals to yyparac. What is this yypars? This is the function when you compile the yuck file. This function will be created. Okay, this function will be created, and this is how from main program you call your parser, the parser that you will read in. Okay, so now we will check if status after calling this parse, it will read the file, the Verilog file, and it will do something. If it succeeds, then it will return 0, and we'll capture that integer value in status, and we'll check if the status is still 0, then the file ran successfully. Your compiler ran and read the file successfully. At this moment, there is no grammatical error or syntax error in the file what you have written. So where this file um, will be, it will be written in vi tool.y. I'll create a yuck file like that, and um, so this is the skeleton of an yuck file. What is there? Same as a LX file, within percentage, open curly braces. Then this is for the C program, std out. And now I am saying that start. What is start? Design description. I'm not saying that module item, blah, blah, source list, something, design description. Here, what we'll do, design description. So start could be design description or nothing. Okay. And this is a like customary thing. Uh, some error. If there is error, it will give the this thing. So this is typical thing. You whenever you read it, this is standard structure. So we'll start like this. Only one rule, and all non-terminals. We are not described this thing. Okay, and we'll get error for this. Just look at it. How I resolve this error, and why I am resolving in this error. I'll save it, and I'll come out, and I will call Bison to compile it. Bison minus t minus d minus o yuck.c. This is the standard way. I'll send you the details in the WhatsApp group. No need to worry. Just look at it. So design description is used. Symbol design description is used, but it is not defined as a token, has no rules. See this error, and again see this thing. So it is neither a token. So what it is looking for, either it should be token. Token means terminal, or there could be rule for that. There could be like this. Oh, then something I'll write here, and then it will be happy. So I did not do either of them, any of them. But because I'm just starting, okay, and as a developer, you cannot complete the rule like this in one day or something like that, or just like that. So what is the technique? What is the technique to use? The technique to use, and let me know if the fonts are okay, or let me improve, increase this. Otherwise it will be difficult to look at. 12 is already there. Let me make it still 14 close. Okay, I hope it is even better. So what I'll do, I don't have time, I have to go now, maybe, because we are all human being. It is all like in the night, you don't want to work. For the time being, to get it pass, just do this thing. percentage token okay, I have placed it in the wrong place here. So after this percentage close curly brace and before this percentage, I have declared this as a token, but it is not written by Lex or Gperf for the time being to keep the yak happy. I have done that. Then if I compile it, fine, no error. So this is how you should fool for the time being the yak. And if you do that, what you have got, you have got a file called yak.c, and which was the output here, which we tried to do here, yak.c. Now if I open yak.c, see it is 1250 lines, and see what is the length of tool.yak file. It is this many, 17 lines. This has created a 1250 lines of code. If you have to write this yak in C, pure C language, you have to do this kind of this amount of coding. So that's why it saves your life. And here it will create what I was trying to show. This is the function it creates, and this is the main function which you should call to read a file. The same thing. Oh, sorry. We have done it here, static equal to yy parse. But if I want to compile it, and also last time what we created tool dot lex, let me delete these also, and okay, so only one I didn't this is what we are calling it a DL code, and this thing we are calling this thing from gperf. This is the function we created here, and we wrote some amount of kind of keywords. So this was our skeleton structure. So what we'll do, we'll compile flex, the lex file with the flex. We have compiled by yak file with bison. Then we compiled gperf, a file with gperf. Now what we have, all these things has created lexer.c for lex, tools dot yak.c for yak file, and gperf file will create tools.gp.c. This C files has created, and we have our tools.cpp. This is the main skeleton structure. So now what we have to do, G++, So what we are doing, the command we have asked is g plus plus minus o my tool. This will create a my tool executable. Now we are compiling this, our main file, the lex generated C file, yak generated C file, gpub generated C file. Then all these functions will be created in the respective files, and from tool.cpp we can call those things. Okay, so still there will be some errors, and that has to be resolved by these things. The main problem is like this. Error was not declared in this code. YY parts is not declared. So for this thing, I have to, what I have to do, general thing, vi tool dot cpp. I have already done it to save time, so I'll just copy paste here. So this external, so because I'm not defining this thing here, it is defined in some other file, so I have to define this function as extern file. So if I do this, then it will get the definition, it will not complain at least. Or let me see my tool, I have to delete this. Okay, still not created, there will be some problem. This RDL keyword, this is another in gperp. So what we have to do, basically not here, vi tools.l. Here in the lex file we have to, because in the lex file we are calling this function, but it is defined in the gperp file, so we have to define this as extern int in the lex file tool.l. Here we are using this thing, but it is already defined, but somehow it is giving error. We'll check later. Okay, what else? Yak.age vi tool.cpp st.h. Okay, maybe we have to okay, this is fine. This is fine. Then what is the error? Identifier was not declared. So identifier should be there. Return identifier. I think I have to define percentage token identifier.
Alok, do you need yak.h somewhere?
Yak dot
H.
h I have included.
Oh, okay.
Hmm. Okay, so let me not try to do this here. I think everything is perfect here. Um, Let me. Okay, so this is how it looks like. So I have done this thing, and PI CP. Yes, now it is created. Um, okay, so let me show you tools.y. So okay, this was the problem. Y by line number. Okay, fine. I think yes. Okay, so this is the thing I have developed so far. So here, this design description, then I have elaborated this, and one rule I have created. Um, what is that rule? Just first description. Okay, the first description, module description, K module. This was defined in the zipper file. PI. See, module as a keyword I have defined. Then identifier. Identifier will come from where? From this. Identifier will come. Return identifier. And L PRNTH, L parenthesis. What is that? It is not defined here. Where it is defined? See, left parenthesis. This I have defined here from Lex file, like R parenthesis, right parenthesis, then semicolon. These I have defined as a token here, and they are coming from this Lex file. So I have created this tool, K module. K mod means module keyword, then identifier, then left parenthesis, then port list opt, then right parenthesis, then semicolon, module items, opt, and K end module. Now, if I expand each of them, K module is a terminal because it is a token. Identifier is also token. I don't need to explain them. This is also a token, L parenthesis. Port list op is a non-terminal. I have to describe this. What is this port list opt? Means list of ports. Module can have a list of ports or maybe empty. So port list or empty, nothing. That is the like elaboration I have done. Then this is also a terminal, this is also a terminal, means token, but module items opt is not a non-terminal. Then I have described them also, this as a module item or nothing. After that I didn't have time. Module item is not described. For that, what I have to do, I have to make, for the time being, I have to call it as a token. And similarly, UDP, I have not defined yet because UDP is a separate thing. I need lot of time. So I did not like elaborate it. This is a non-terminal, but for the time being, I have defined as a UDP declaration. Okay. So similarly, port list, what could be the port list? That also I did not elaborate, so I have made it this thing. So Yaki is happy, and I have got my compiler, this my tool. Okay, now I have to create a test case. You have to now test your compiler. How to do that? The main thing is you have to create a Verilog file. What I have created as a rule, what I have created, module identifier bracket port list opt bracket semicolon module item opt end module, means module keyword, then identifier, then bracket optional port list, means if I don't write anything, that is also fine. Then semicolon is must, then module items. Module items opt means module item could be there, may not be there. So if I don't write anything, that is also according to the rule what I have created here. And after that, end module, which is must. So this is a skeleton. Verilog file. If I want to run my tools dot test one.v, it should run, but it is not running because of one thing. I have to tell you, tool dot y, sorry, cpp. So here we have not mentioned what kind of file it has to read. See what file you have to read. For that thing we have to make a declaration here, extern file star yy in. This yy in is a standard thing. It will come from the YAC file, and here this, sorry, we have to say yy in equals to if open, rather I'll copy from here. So what I am saying, if open the file in read mode, the first argument that day I have showed, like for command line parsing. So now yy in is the file handler, but we don't have to pass it here because yy parse, like by the convention, it will look for yy in file. If I open yuck dot c file, okay, yeah, it should be fine. File star yy in. So it is fine. By default, it is there. So if I do this thing, then if I compile it again, the file ran successfully. So this is a basic, very basic compiler. Now we are done. Okay, so now this is a positive test case. Now we have to make so that we can prove that yes, if it is wrong grammar, it will fail. That is also our job to make sure. For wrong thing, it should fail. Suppose if I don't give this end module, syntax error at line number. See, now you feel right, you when you do C coding, you get this kind of error. Now you have created a truly a practical compiler. So like that thing. Suppose I write something end module, and I write here ddd something, some weird text. If I save and if I try to compile, compiling means my own executable what I have just created with the Verilog file. So syntax error at line number 1. Okay, like that. So it will give you the line number also where the problem is, and it gives like this. It will if the problem is here, if it will give the line number, this last correct line. Suppose if I do like this after end module, like that. Okay, it is not giving the line number properly. We have to see later. So this is the complete test. Whether it will give you the wrong thing also, wrong. It will give you the right thing also, the right one. Uh, and this is called test cases, and this is called unit test cases, where you will do small test files, and you will check that your compiler is doing correctly. Now coming back to the project. So what we have done so far, this is like, let me also copy this to here, and let's give it a little bit of professional get up. Toolsmith back dot cpp dot d. See, welcome to SEDA Bangalore, Toolsmith Verilog compiler version 0.1, reading file test.1.v. The file ran successfully. It looks now kind of commercial tool or professional tool, at least looks professional. So this is just ornamental. How I have done this? Just some printf statements nicely. Then while opening this file, I have given this file name and reading file %s, simple printf statements. Then I have done what is needed for this mechanism, and I have compared the status, which is written by the YY and if the status is fine, I have given a status message. The file ran successfully. Now coming to the project, right? Vi tools dot star. Let me. So this is CPP I have shown. So GP, I have used only this 5 keywords because my rule is that only. But if you see that the here you can create a lot of rules, right? But you don't have to create lot of rules. Try to do incremental improvement to this tool. I'll share this skeleton code to all of you. So what we have done so far, this is the gperf file. This is lex file. For lex you can use like this only, no issues. See this yak file, I have created only module port list opt this thing. Now this port list could be what you have to do, what we do generally, the compiler developers, we expand. Now port list could be what, the same recursion you have to add, port list comma port or port. So what I have done, I have still told that port could be port list, could this comma port means what, in that presentation, right? What was there? um, See out comma in one comma into this you have to add. So far the code I will send you, it doesn't cannot parse. The rule is not there. Why? Because this port list I was not, just now I was writing here, and it will be like this: port list comma port. And what is a port?
So there is uh, is there any time restriction?
No, sir, there should not be time. There should no time restriction. But just give me some time, sir. I'll just see why this happened.
Okay, fine. Yeah, Alok is joining in a minute. Just yes, Alok, we can start now.
Alok, sir, you are muted.
Okay. So what I was saying that vi test.v. See, now this is a typical, earlier it was fine. Now if I want to add this feature, like there could be port list of module, which is very natural. If I try to compile by this thing, see, it will be syntax error. So now I have to enhance my uh, this thing, enhance my grammar. So why that is happening? Because port list, I have not told it is port list. It is coming to this default like optional, but there could be port list. But I have not told what is a port list. Then what I have to do? I have to add a rule. Okay, port list could be port list comma identity, not copy paste. Okay, identifier or only identifier, isn't it? This is the rule. Port list means recursion identifier. This basically means identifier, comma, identifier, comma, identifier, comma, identifier, anything, any kind of recursion it will cover. So if I enhance the rule like this, then I
But you
have,
also have to define comma, right?
yes, right, define comma also, exactly. So where I have defined it, I have to define it, I have to define it here. Comma is
Okay.
comma,
Yeah.
lex file. Okay. And also here I have defined this as a token. Then lex is generating the token and yak is getting this, and this definition is here, so everybody is happy. So now I have to compile Flex, I have to compile Bison, then okay, but I'm still having that definition. Port list is a token, but I have expanded it, so I don't need to define it. I have to delete port list from the token list. If I again this thing, it is happy, then G++, it is happy, then it is fine. So earlier it was giving error, now I think it will not give error. See, ran successfully. So I have enhanced my compiler to accept this syntax also, which is valid, right? So now your job for the May that final presentation, add as many rules as possible, but don't take it like a burden or something. Add, enjoy it. See, one, two, 3 lines, just understand and add one more feature. See here, module items is empty, I have kept module items opt, means optional. So optional means what? There may not be, by the, because of that rule optional, it is not giving any error. But optional is valid, that is also, you can have an empty module, that is perfectly valid. Do not delete this optional thing, but try to elaborate module items or take any other feature from this, right? Take from this module, like module parameter port list, add this expansion and do whatever you want. Little thing that would be your project. And Girish, you can now announce that, and they should now gear up for this project. So kind of what the basic things I have covered. Now they can create their compiler. Now it is complete. All the files, skeleton should be there, and now they should add one more and more, adding the exactly the same way I used to do in my job. That is the exact same job description. If they join Synopsys as a developer or Cadence, they have to do this kind of job. Each day, a new enhancement. That is their project. Let them enhance, add more and more grammar or rule basically to this compiler. And next session, I'll say what should be the C++ code, how to store the module, design tree, how to create. I'll cover that next. And when it is covered next time, then they can add it to their this compiler. But they are good to create the skeleton of their compilers. Thank you. That's all I had today.
Thanks, Aloke. It was very informative. I really enjoyed this session and also learned. And the participants, yes, as Aloke said, I think we should start planning for building your project. And Aloke will share the skeleton code, and you start adding as per his advice that you should have more and more features and test. And in addition, I would like to challenge you. Can you bring some innovation to this? can you think something differently and bring some innovation to this? So that will decide the winner for a project.
Exactly.
Okay, and yeah, following the whatever Alok said is something. That is one thing. That is basic requirement, number of features, and what you can do more than that. What is not asked for. So that is a challenge. So please start your project and please ask for any suggestions. And we are available on WhatsApp. And definitely we are looking for forward for your presentations, projects, discussions, everything. And even we will be learning from you. It's not a one-way traffic, it's two-way.
Yeah, I'd be really happy if somebody can make a small compiler. It's like earnest request.
Yeah.
From India, we should be doing this thing, not only the users. And many people can say, okay, this is a standard format, AI can do it. Obviously AI can do it, and in future this role will be okay, maybe. But AI needs to learn, right? This LRM, language reference manual, it has to learn. How it will learn? There also it will be one compiler would be needed, parser would be needed. So the requirement for reading something for a computer, for AI has to also learn, right? So that learning will happen through a compiler. Obviously, there is no other way. So it is an evergreen topic to learn. This job, compiler developer, will not be eaten up by the AI.
Yes, and it incorporates a lot of basics of computer science. They're all transferable skills. It does not for a compiler itself. You can do a lot of things with this basic knowledge.
Exactly.
Yeah. So you don't have to get fixed to compilers also. You can do a lot of other things. So that's what I was said. What you can do differently. That's what we would like to see. And as far as the team's composition concerned, anyway, I'll send a message. Please make it 2 members per team maximum. And please send a proposal. Let's see.
Correct. So one language, Verilog, everybody will be working on Verilog.
Yeah.
And who can add most number of features, maybe Girish, you can give award or
Yeah.
judge on that thing.
Yeah. Sure.
Maybe. And what you have done, something different, what
Yeah.
we did not ask for.
Yes. Yeah.
So before leaving, I request everyone to switch on the cameras. I request once for everyone to switch on a camera for a group screenshot, please. Okay, guys, please give a nice smile. On a count of 3, 2, 1. Yeah, let me take one more. Just give me a second. Yeah. On a count of 3, 2, 1. Yeah, thank you, guys. Girish, sir, over to you.
Yeah, thanks. That's all from my side. I will post all the messages in the WhatsApp group regarding the projects. And please, I expect the participants to make it more interactive. You should ask more questions, discuss your points, and that's how we learn. Yeah, good night, and thanks for attending.
Good